Hey everyone! Today we're going to jump into a super cool number mystery, one you might have even bumped into in math class. We're going to find a hidden pattern right where you'd least expect it.
So let's get right to it. Here's the big puzzle for today. Imagine you take any four numbers that are right in a row. Now you can put plus or minus signs between them in any way you want. So what's the one thing that all the possible answers will have in common? Any ideas? All right, you ready for this? We're going to be number detectives today. Let's put on our thinking caps and investigate this thing together, one step at a time.
Okay, first up, a curious number puzzle.
Now, every good investigation needs some evidence, right? So let's start with a really concrete example. We'll use the numbers 3, 4, 5, and 6 as our first set of clues.
Okay, so we can throw in plus and minus signs in all sorts of ways. Let's just try a few. If we add them all up, 3 plus 4 plus 5 plus 6, that gives us 18. What if we just swap one sign? 3 plus 4 plus 5 minus 6, that equals 6. And get this, if we go all negative, 3 minus 4 minus 5 minus 6, we actually get a negative number, minus 12.
Okay, take a good look at those results on the screen. 18, 6, 8, minus 12. Are you seeing what I'm seeing? Is there some kind of connection here? What do all these numbers share?
All right, let's see if we can really nail this down. It's time for uncovering the pattern.
You know, a good detective always double-checks their clues, right? We got to make sure that first set wasn't just some weird fluke. So let's try a different set of numbers, 7, 8, 9, and 10. We run the numbers, do the math, and we get results like 34, 14, 20, minus 14. Looks like that pattern is holding up. And there it is. That's the big reveal. If you look at all the results from both of our tests, every single one of them is an even number. That's our common thread.
So this slide kind of makes our finding official. It says the results always have even parity. Parity. That's our keyword right there. But what in the world does that actually mean?
And that leads us perfectly into our next section, the secret of parity. This is where we're going to figure out the why behind this whole thing.
You know, parity sounds kind of fancy, but it's actually a super simple idea. It's just a word for whether a number is even or odd. That's it. So when we say something has even parity, we're really just saying it's an even number. Simple as that. So parity has these really simple basic rules. An even number plus an even number, well, that's always going to be even. But check this out. An odd number plus an odd number is also even. The only way you can get an odd result is by mixing an even and an odd. And believe it or not, these same rules work for subtraction too.
Okay, we've spotted the pattern and we know the rules of parity. Now it's time for the final piece of the puzzle. It's time for cracking the code. So the big question is, how can we be absolutely 100% sure this works for every single set of four consecutive numbers? I mean, we can't test them all, right? The answer, like the hint says, is algebra. And this right here, this is the secret weapon. Instead of using specific numbers, like 3, 4, 5, and 6, we can use a variable. We'll call it n to stand for any starting number. So our numbers become n, n plus 1, n plus 2, and n plus 3. This one little expression can represent every possibility out there. Now here is the really, really cool part. It doesn't matter what number n is. If you pick any four numbers in a row, you are always going to have two even numbers and two odd numbers. Just think about it for a sec. It's either going to go odd, even, or even, odd. The pattern is baked right in. And now we bring it all home. We know we're combining two evens and two odds no matter what. So, what happens when you add or subtract two even numbers? You get an even number. What about when you add or subtract two odd numbers? You also get an even number. So now we're just left with two even numbers to combine, and an even plus an even is always, always even. Case closed. How cool is that?
But this whole idea of parity, it's not just a one-trick pony for our little puzzle. Let's see what happens when we go beyond the puzzle.
All right, your turn. A quick pop quiz. Now that you're a parity expert, take a look at these expressions. Can you figure out which ones are always going to be even and which ones are only sometimes even?
Let's break down a couple of these just to see. Let's take 4m plus 2n. Well, any multiple of an even number is always even. So 4m is even, and 2n is even. And we know an even plus an even is always even. But now, what about x squared plus 2? If x is an even number, like 6, you get an even result, 38. But if x is an odd number, like 3, you get an odd result, 11. So that one is only sometimes even. See how that logic works?
You know, this quote really gets to the heart of what makes math so incredibly powerful. It's saying that because of mathematical reasoning, we can prove something is true for all the combinations without having to go through them one by one. It's about finding an elegant proof, not just doing endless calculations.
So I think the real takeaway here is that math is just full of these beautiful, hidden structures. And that leaves us with one last question to chew on. How many other mathematical rules that we take for granted are just hidden patterns, waiting for a curious detective just like you to come along and discover them?